Hi, my name is David Johnson, researcher and software engineer at the University of Utah. And in this presentation, I'm going to describe our efforts towards building an automated and continuous ORAN testing framework on Powder. The University of Utah has been involved in multiple ORAN plugfests now, and one comment that we've gotten from participants is that it would be useful to run complex ORAN integration tests at any time or continuously, and not just during the shorter fuse time of a plugfest. So there are lots of ways that Powder already enables this kind of automation. Although our experience in the ORAN plugfest is typically semi-automated, Powder provides profile building blocks that have some amount of automation in them. For instance, a Kubernetes profile, or an OpenStack profile, or an ONAP profile. And these enable experiments to be torn down and stood back up very quickly, and vendor software can be added on top of them. The platform is already remotely accessible, and it's accessible on demand or by reservation. And as I said, the Powder profiles already are composable into these interesting multi-vendor integration scenarios. Moreover, Powder provides APIs that can be used to automate this testing. So how can we take these pieces that we already have and build an even more powerful automated system is the question we've asked. So let's describe what Powder offers today. So Powder already offers these profile building blocks, and a profile is simply a description of an experiment that you want to run. It's the hardware resources that your experiment needs, how they're connected in physical and virtual or wireless networks, the software that runs on the physical or virtual devices, and its configuration, and additional hooks to enable further configuration on top of what Powder already provides at the base level. So how can we generalize this and make it more powerful for automated testing? So what we've chosen to do so far is expose our building blocks and our API interfaces in both workflow and configuration management systems. And we believe this is going to encourage better composition and reuse and increase the automatability of these complex test scenarios. Our design uses a workflow engine running in a profile, so the workflow software itself is a building block that can be integrated into existing Powder scenarios and profiles. And the workflow engine is what runs these automated ORAN testing workflows. In this case, when I say workflow, I just mean a directed graph of actions that could potentially call other workflows as well that automate test processes or configuration processes. Workflows commonly offer actions that can be run in parallel. You can loop over actions. You can branch them based on outputs of prior actions. You can rejoin branches so that you can implement barrier synchronizations. And workflow actions typically offer well-defined inputs and outputs according to some schema, sometimes a very minimal type-like system. And workflows can often be triggered from outside systems by events, for instance, like a source code commit. So here's a high-level overview of what this system looks like in Powder. So at the top of the big yellow box is our workflow engine that we selected, named Stackstorm. And Stackstorm, as I said, runs in this workflow manager profile. And we've written plugins so that it can integrate with Powder and a test case management system called Kiwi TCMS. So Stackstorm can run the testing workflows, and their outputs and progress can be tracked in the test case management system. So a testing workflow would typically look like this. the Powder Platform APIs are called through the Stackstorm Powder plugin to create experiments from existing building block profiles or new building block profiles, according to the profile specification. In the second step, the testing workflow will likely go through some amount of configuration management hooks on top of what the Powder platform already offers as a base configuration. Things like what happened in the cloud, virtual network or physical network configuration, base image deploy, user pub keys and user accounts being created, and things of that nature. The configuration management is for automating larger pieces of software configuration on top of that base config. And we've chosen to push on Ansible to fulfill this role. In the third step, the testing workflow executes tests once the environments to be tested or the testing environments have been stood up by steps 1 and 2. And we've dropped the robot framework in there as an icon, but really we intend this approach to generally cover any kind of test execution framework. And similarly for the test case management system in step 4, where the results are pushed into the test case management software. It would be ideal if all test cases could be very fine-grained, and if all test execution frameworks could be refactored slightly to push into the test cases that we define for ORAN testing. But this is unlikely to be reality. There are large existing testing suites, so we want this framework to generalize to push whatever it can into the test case management system. The main thing is that everybody pushes into a single place. So here's our eventual vision and the demo that we want to get to, is to provide this automated near real-time RIC test workflow where the user instantiates this workflow management profile to get their own private Stackstorm workflow engine and test case management area to play around in and to trigger the workflows. Triggers from external systems, of course, could trigger these workflows as well. And then the workflow engine simply runs the test cases and test scenarios that are loaded into it. So the workflow in this case, we would have in the left column there a RIC testing software stack. Could be an off-the-shelf testing stack provided by a vendor, could be an open source stack, whatever the case may be. And in the second column, we have the instantiation of the base ORAN profile, which for Powder provides the OSC and Open Networking Foundation SD-RAN RICs. And both of those are stood up by invoking the Powder API through the Stackstorm plugin. And in step 3, a bit of Ansible and Powder automatically generated entry points are invoked to reconfigure the Kubernetes or the deployed RICs according to the parameters of the test. So we've written some Ansible automation so that nodes and networks that are enumerated in a Powder profile may have Ansible playbooks and roles bound to them in the profile, and then experiment runtime shims that we provide automatically generate these entry points so that the user can call them at a high level without worrying about the details of executing the Ansible with the right overrides and the right playbooks and getting the overrides to the right place to change the configuration of the system. In step 4, we would reconfigure or configure the RIC test software according to whatever the vendor or test suite provides. In step 5, the workflow would invoke Powder APIs to connect these two experiments so that the testing software is only connected to the system under test for the duration of the test and no longer to provide the strongest isolation that we can. In step 6, the workflow would trigger the test execution framework, and in step 7, the results would be reported into the test case management software. And obviously there's some blur in steps 6 and 7 depending on what the testing software offers. So in this demo, we're going to take a step towards that. We'll demonstrate the pieces in the red boxes, and the demo will use the Open Networking Foundation's SD-RAN near-realtime RIC, and we'll do some basic smoke tests on those pieces with a number of parameterizations. So we'll just have a single RIC under test experiment. In this case, we won't actually have the robot framework or another test framework executing tests. We'll just have them run directly from Stackstorm and provide their outputs directly into the Kiwi test case management software. The workflow will execute the tests over a few parameters. We'll have some different Kubernetes configurations with different virtual network plugins, and then with the 2 publicly available SD-RAN software releases. So a little bit more detail on how these powder building blocks work and how they enable automation, extra automation and extra composability beyond what we had already had. So we have this new building block, this new workflow manager profile that users can allocate and then launch workflows. We've integrated this workflow engine named Stackstorm that can run these workflow building blocks, sometimes through the Powder API or through Ansible reconfiguration, those automatically generated Ansible entry points. And the nice thing about Stackstorm is that it provides a large library, or exchange as they call it, to enable further integration with other systems via their plugins. Think clouds or Kubernetes or AWS, or even just more smaller things, just running a Linux command or running a remote shell command and triggering something via SSH. So Powder can stand up these workflow management experiments with your Emulab credential or with your Powder credentials, so that you can have your workflow execute additional Powder experiments and tear them down and compose them as you'd like. Stackstorm does support these partially automated workflows that occasionally require remote hands, and we expect this to be important in the O-RAN ecosystem. It's unlikely that we can avoid all forms of manual plug testing, thinking down to the lower layers of the front haul or the RF side of things. But Stackstorm supports this very easily and essentially pauses the workflow until the human fulfills the pausing request on the branch that's needing to be paused. And then the workflow can continue. And these workflows do have well-defined inputs and outputs. They're typed. They can say whether they're required or not, and this is defined in terms of JSON schema. So this lends workflows towards composition. And we've started to work on developing a library of O-RAN test workflows for the open source O-RAN pieces that we're aware of. Speaking more towards a configuration management perspective, historically, as we've operated test beds, we've tried to stay away from pushing users into any one configuration framework or execution framework. Inevitably, users want to do a very, very wide variety of things, and we don't want to limit that. At the same time, the most widely used form of automation after the Powder platform has laid down the base configuration is shell scripts, and this is natural. They're ubiquitous. They're accessible. They're easily written. They're easily tested. But they're not very maintainable, and when they become large collections, it's impossible. It's very hard to reuse pieces of them, simply because they lack these well-defined inputs, outputs, interfaces. So we've chosen to pursue an Ansible integration because this is one of the easier configuration management systems. So we've begun to recast our complex profiles to use Ansible, those that didn't already use it before or use it for portions of their configuration. So we've added Ansible plugins to contextualize Powder from a runtime experiment environment perspective. Facts about the experiment are made available for use in Ansible playbooks and roles. We've made it easy for you to add playbooks and custom playbooks and roles to your experiments, and then have our Ansible shim just automatically execute them according to the bindings that you've defined in your Powder profiles. And we, as I mentioned before, we try to generate these Ansible entry points so that major important playbooks can be remotely triggered, so that reconfiguration can happen on a broad and fast scale in a reproducible manner. So this provides some amount of composability. There's some amount of input and output definition here, but of course when you're composing multiple playbooks and roles, there's always questions of who owns what resource on the system. And so there's always an amount of test coordination, so composability isn't just a given. There's testing and care that must be taken to make sure that overlap does not break things. So thanks for watching this. If you're interested in any of these automation possibilities for ORAN testing, please contact us. We'd welcome those conversations. Thanks very much.